Hey, this is Mr. Mitchell with a video about science. Science is more than a collection of facts. Science is, well, it's a process. And this process leads to better understanding, a more thorough understanding of things like the earth, like of space, of human body systems, or even of the limitations of our world around us, the physics of the world around us. Scientists and students of science have developed habits of thought that help them make these understandings. Now, these are habits that kind of go beyond just taking something for its word. They kind of like to call these the habits of the mind. Habits of mind. Let me see if I could circle it. It says looking pretty good so far. Yes. Or no. Yeah. Habits of the mind. One of these habits of the mind, of course, is curiosity. A scientist must have enough curiosity to uh, want to understand things. Sure, people can look up at the sky blankly, but if you don't have that curiosity of wondering what this is and what that is and how things move around, then nobody would discover anything about space or about the sky. Another thing that is an element of the habits of the mind is asking questions. And you can see I have this lady here with all these question marks above her head. So, person looking up at the sky, oh, this is awful writing here, isn't it? Well, anyway, person looking up in the sky that wants to learn more about it would probably ask questions. What is this? What is that? And finally, something that I have put with this guy over here is a scientist has a certain degree of skepticism. And you can see this guy is not really believing who the person is telling them. Skepticism. I write so much better when I'm not on this. Well, anyway, you can see three habits of the mind: curiosity, asking questions, and skepticism. Let me talk about this skepticism here. A person who is doing a scientific experiment or who is asking questions, trying to learn things, they don't just accept assumptions of fact. Assumptions of fact kind of need some kind of evidence to back it up. And that's exactly what scientists will look for. So the scientific method therefore involves this. Scientific method involves observation and asking questions, determining what is known and what isn't, then investigating from those questions and what we already know. And then once you do some investigation, then you can kind of try to interpret it correctly and then let others know. So scientists may try several incorrect explanations before they end up coming up with what they think is the truth. And even once they come up with what they think is the truth, it may be proven not to be the truth later on. So let me get to some words you may have seen before. One word is hypothesis. Now, a hypothesis is a tentative explanation for an observation that can be tested. So say you're looking up into the sky. I'll call this an tentative explanation. Well, what it is, it's a guess. So I'll just go ahead and put guess here. A tentative explanation. You're looking up into the sky, and into the sky you see these celestial bodies that are up there, and you observe that they tend to move throughout the night. So you take a guess, like people probably did many years ago, that they are revolving around something. Now, you probably remember from your studies that people at one point thought everything in the sky revolved around the earth. We'll actually talk a little bit more about that. But here's another example over here. Here are two planets. Now, there are lots of planets between the sun and Uranus. This is Uranus right here. There was a point, for example, when people knew that this planet Uranus existed, but they did not know about the next planet. The next planet here is Neptune, but they just didn't know that Neptune existed. But what they did notice is that whenever Uranus moved around in the sky, at certain points it seemed like it wasn't moving quite the same way. That there was a body that was out beyond it whose gravitational attraction kind of made it go out just a little bit more than it normally did. So people actually predicted that there was a planet called a planet that was out past it, and they ended up calling it Neptune once they figured it out. So the hypothesis was that there was indeed another planet or big celestial something out there. Sure enough, over years of time, it was discovered that they were correct. Now, hypotheses are often wrong, but if proven wrong, they might lead to the proof of what is right, which leads us to a theory. Theory is more than just a guess. A theory is a hypothesis that has been tested as a correct explanation and seems to hold up to all the evidence. So, tested hypothesis. And I'll abbreviate that HYP. That holds up, that seems correct, even after all the evidence. Now, that doesn't necessarily mean true that it's true. It just, with all the evidence that you have, oh goodness, I'm just an awful writer. With all the evidence you have, it does still seem to be true. So it's called a theory. A good example here is plate tectonics. There's a point at time in which somebody recommended, hey, what if there are like cracks in the earth and these cracks are moving away from each other? And at one point it was just a hypothesis, but now after years and years of observation and of testing, it does still seem to be true. So you would say that that is a theory of plate tectonics. And of course, in time, some theories are proven wrong. And a good example of a theory being proven wrong is what I was talking about earlier with whether the sun revolves around the earth or whether the earth revolves around the sun. And you can imagine somebody looking up into the sky years and years and years ago and seeing everything that seemed move in the night sky. And it just seemed like all the evidence pointed to the fact that things were rotating around the earth. So it was a theory. It seemed to be true with all the evidence that we had. But the thing was, we just did not have all the evidence. And of course, it turned out not to be true. And you can see the terms we have up here. These are actually terms that are part of the sixth grade science standards. Geocentric is the term that the Earth is the center and the sun has orbits that rotate around it. And heliocentric is the thought that the sun is the center of our solar system as opposed to the Earth. Of course, we know now that heliocentric is correct. But let me kind of talk you through this just so you can kind of see the scientific thoughts that came from it. This guy right here is named Nicholas Copernicus. Copernicus had a hypothesis of a heliocentric model. He kind of thought, well, what if it is the sun that everything is revolving around as opposed to the earth? It was just a hypothesis at the time, but it was something that people could test, that he could test. Now, the thing is, Copernicus here didn't have a whole lot of evidence. So as a result, it really didn't get past the hypothesis stage with him. And not many people really accepted that because, shoot, as you looked up in the night sky, everything just seemed to be revolving around the earth. But it wasn't, well, this guy right here, Galileo, he was born about the time Copernicus came up with this idea. And Galileo, years later, would come up with something that would make it a little easier to grasp the heliocentric idea, the heliocentric model. He hypothesized that a body in motion could appear motionless. For example, here we have this guy on an airplane. Now, there wasn't airplanes at a time, but I guess you say a carriage or a horse or a bus or whatever. He can toss a ball up and hold the ball in his hand, and the ball, of course, is moving just like the vehicle he is in this case, the airplane he is in. He is moving, the ball is moving, but to just be standing here, he doesn't really feel any effects of moving at all. So with that hypothesis, that was something that could be tested pretty easily. You can imagine you can just get different vehicles and different objects that you hold and make observations from there and see, something can be moving and it doesn't appear to be moving. So that made it so much easier to realize, hey, the earth could be moving too, even though the perception is that it is not moving. So it was Galileo's hypothesis that helped prove Copernicus's hypothesis. So that's kind of how science works. Looking at my notes here to see what I have missed. So here's the question. How can thinking like a scientist be more useful in our lives? Here's an example. It's useful to our understanding to have a healthy skepticism to ads that say, well, doctors agree, for example, or experts agree. Here's a doctors who agree, ooh, smoking's good for you. Yeah, we kind of know now that that's not really the case. But just because a doctor says something in an advertisement, we don't just go, yes, we agree with what the doctor says. So whenever we are consumers, we don't want to just take word for it. We kind of want to be able to have some independent thoughts about whether something is good for us or not. And just because something is advertised doesn't mean that it's good for us. Way back in the early 1900s, here's heroin. Now it's an illegal drug, dangerous drug, but it at one point was sold over the counter apparently. And here's an ad here: buy your heroin. What about cocaine drops? Yeah, cocaine at one point was legal, and people advertised and wanted to sell it. What about this? The Soda Pop Board of America recommended that infants, instead of having mother's milk, have cola. I don't know about that. What about this one? Oh, just because you have a famous celebrity advertising something doesn't mean that you go out and buy it. You have a little bit of skepticism about it. And, of course, there's Justin Bieber. Finally, whenever you are a consumer, for example, you want to read labels. You want to do research. Sure, you may come up to the same conclusion that, well, this happens to be the best nail polish for you, but you came to it outside of whoever famous celebrity happens to be there. You just want to come up to conclusions with a little bit of evidence to it. Because if you don't, you might be just like many people who just assumed that the earth was the center of the universe. Hey, I hope you've learned a little bit about science.